This presentation provides an overview of the Aparian Modbus Series B router, which can be used to connect Modbus TCP and Modbus RTU devices to Logix controllers, SLC, and MicroLogix PLCs. In this presentation, we will introduce the product, show typical architectures, describe the ease and simplicity of configuration, and show the module's extensive diagnostic capabilities. The Aparian Modbus Series B router was tailor-made for integration with Logix controllers. It leverages the powerful capabilities of Ethernet IP to make configuration and support simple and straightforward with the use of direct-to-tag technology. The Modbus module can operate in one of three modes: scheduled or master mode, where the module initiates all communication; reactive or slave mode, where the module responds to data requests; and unscheduled mode, where the module transfers messages received from Logix message instructions. Now, let us look at some of the Modbus router's key features. Both the RS-232 and 485 serial ports are isolated. The module supports Modbus TCP and RTU and can convert messages between these networks. The dual port switch reduces the need for additional hardware when connected to a remote RTU and enables the module to be added to a device-level ring, or DLR. Another feature that sets this module apart from the competition is that it can connect to Logix via USB or Ethernet. This feature allows two Modbus routers to be used in a redundant configuration with redundant controllers. Lastly, in reactive mode, the module supports multiple Modbus node addresses. This enables the module to respond to different node requests, enabling the replacement of multiple routers with a single Aparian device. Now let's take a look at some typical network architectures where the Modbus router may be used. In this topology, we see the Modbus router in the scheduled or master mode connected to one or more devices on a Modbus network. On the left, we show a USB connection to Logix, while the right diagram shows the more typical Ethernet connection. This example depicts the module in reactive or slave mode, providing data to a SCADA system over either an Ethernet or serial network. This third topology demonstrates how a pair of Modbus routers may be added in a redundant ControlLogix controller setup. We will now look at how the module is configured. As with all Aparian products, the Modbus router is configured using the Aparian Slate configuration software, which can be freely downloaded from our website. The first step is to populate the General tab by giving the module a name and setting the IP address, which can be done using the target browser by clicking on the ellipses button on the right. Next, select the controller mode and mapping mode. When configuring the module in scheduled mode, mapping can be added to as many as 3 different controllers. Each requires a reference name and SIP path, which again can be obtained using the target browser. 4 scan intervals can be configured for 4 different update periods. Lastly, the mapping of Modbus elements to tags needs to be set up. This includes selecting a Modbus function, associating a scan interval, the Modbus node address, and the elements to be included together with their data type. The target name entry will provide a drop-down list of the target names entered above. Lastly, the target tag can be selected using the tag browser. This is usually the first element of an array large enough to accommodate the number of elements selected. Setting up reactive mode is very similar to the previously shown scheduled mode. Note that different Modbus nodes can be used for each mapping, which adds flexibility to the configuration. Now the configuration can be downloaded to the module and the project can be saved for future use. The Modbus router does not have to be added to the Logix I/O tree to enable it to exchange data, but we recommend that it is added to a controller for monitoring status and extracting diagnostics. An EDS AOP makes this task very simple. Now let us look at some of the status and diagnostic information that is available. Diagnostic information can be found in Slate by going online with the module and opening the status window. This information is also available in Logix as shown in an earlier slide, as well as on the module's web server. This data is aimed at assisting with commissioning as well as operational support of the module. The General tab contains overall module data, while the remaining tabs provide communication statistics. Here are examples of the Modbus statistics showing successful packet read and write counts. These statistics can be extremely useful in diagnosing an incorrectly configured system, from missing tags to node mismatches and timeout errors. The Mapped Items tab, as shown on the bottom right, clearly shows which mappings are working correctly. The module also has a built-in packet capture tool, which displays sent and received Modbus packets. This tool provides a window into the Modbus network and can be an indispensable troubleshooting tool. The captured packets can also be saved and emailed to assist with remote support. Here's a screenshot of the module's web server, displaying the same diagnostic data displayed in Slate. Thanks for watching, and for more information, feel free to contact us.